Look up at the night sky. What do you see? A blanket of absolute stillness. A quiet, peaceful scattering of silver diamonds against a canvas of infinite velvet dark. It feels permanent, doesn't it? It feels like a sanctuary of eternal calm. But this is the universe's most beautiful illusion. Behind that quiet twinkling lies a reality so violently powerful, so mind-bendingly terrifying, that it defies all human comprehension. Tonight, we are going to leave the safety of our small blue world. We are going to travel across the freezing, silent ocean of space. We are going to stand on the edge of oblivion and watch the most devastating event in the cosmos. We are going to witness a star tear itself apart. Take a slow, deep breath. Let the heavy weight of your daily life melt away into the floor. As we drift further from Earth, let the immense, quiet scale of the universe hold you. Close your eyes, or keep them open. Just listen. The story of a dying star is a story of terror, yes, but it is also a story of mesmerizing beauty. And by the end of this journey, you will never look at the night sky the same way again. To truly understand the horrific majesty of a stellar explosion, we must first understand the fragile, delicate life of a star. Imagine a star not as a solid object, but as a colossal, raging battlefield. It is a sphere of superheated gas, millions of times heavier than our entire planet. For billions of years, a star is locked in a desperate, unending war against itself. This war is fought between two unimaginable forces. On one side there is gravity. The sheer, crushing mass of the star is constantly pulling inward, trying to collapse the star down to a single, microscopic point. On the other side, there is nuclear fusion. Deep in the heart of the star, at temperatures exceeding 15 million degrees, atoms of hydrogen are violently smashed together to create helium. This explosive reaction generates an outward push, a fierce pressure that pushes back against the crushing weight of gravity. This perfect, delicate balance is called hydrostatic equilibrium. It is the only reason a star shines. It is the only reason our sun provides us with warmth. But what happens when the fuel runs dry? What happens when the outward push begins to fail and the monstrous, patient force of gravity finally takes over? The star's peaceful life ends and the true terror begins. But what exactly triggers this cosmic apocalypse? It all begins with a terrifying silence deep within the core. Imagine a roaring furnace that suddenly runs out of coal. For millions of years, the massive star has been happily burning hydrogen, turning it into helium. But eventually, the hydrogen in the core is completely exhausted. The outward pressure of nuclear fusion, the force that held the crushing weight of the star at bay, suddenly drops. It is a moment of fatal weakness. Many people believe that a star simply turns off like a light bulb when it runs out of fuel. But the truth is much more dramatic. When the fuel stops burning, gravity instantly takes control. The entire weight of the star, billions upon billions of trillions of tons, comes crashing down on the core. The core begins to shrink, squeezed by an invisible, inescapable hand. As the core is crushed inward, something incredible happens. The pressure becomes so intense, so suffocating, that the temperature skyrockets. Imagine squeezing a handful of snow so tightly that it turns into boiling water. The core heats up to hundreds of millions of degrees. The star is trying desperately to save itself. It is fighting back against the dark. In this unimaginable heat, the ashes of the first fire become the fuel for the next. The helium that was left behind suddenly ignites. The star is burning its own waste to stay alive. This new fire is fierce and violent. The sudden burst of energy pushes outward with tremendous force, causing the outer layers of the star to swell and expand massively. The star begins to transform into a monster. Imagine a balloon inflating, growing larger and larger until it threatens to swallow everything in the room. The star swells into a red supergiant. If our Sun were to undergo this transformation right now, its outer edge would swallow Mercury, then it would swallow Venus, and then it would completely engulf the Earth in a sea of red-hot plasma. The sky would turn into a blinding, fiery wall. This is a common myth that a dying star just shrinks away. In reality, before it dies, it grows to a horrifying, monstrous size. It becomes a glowing red titan, dominating the space around it, burning furiously against the dying of the light. But this red giant phase is merely a delay of the inevitable. The helium fuel, though burning hot and fast, is limited. Soon, the helium is also exhausted. The furnace goes dark once more. Gravity, patient and merciless, resumes its crushing embrace. The core collapses again, heating up even further. Now the temperature reaches 1 billion degrees. The pressure is beyond human mathematics. At this extreme threshold, carbon begins to burn. Imagine a fire so hot that it consumes solid diamonds in a fraction of a second. The star is layering itself like an onion, with different elements burning in different shells around the center. The timeline of the star's life is accelerating rapidly. The hydrogen burned for millions of years. The helium burned for a few 100,000. The carbon will burn for only a few 100 years. The star is in a state of sheer panic. It is burning heavier and heavier elements, desperately trying to keep gravity from crushing it into oblivion. Oxygen begins to burn, then neon. The changes that took millions of years are now happening in centuries, then decades. Imagine a clock ticking faster and faster, the hands spinning in a blur of motion. The star is racing toward its final, fatal mistake. And then, the ultimate poison is forged. Deep in the very center of the star, the intense heat and pressure fuse silicon into iron. Iron is the kiss of death for a star. It is a cosmic dead end. Every previous fusion reaction produced energy, pushing back against gravity. But iron is different. Fusing iron does not release energy, it absorbs it. Imagine throwing wet sand onto a roaring campfire. Instead of fueling the fire, it smothers it. The iron core grows, heavy, cold, and dead. It is a silent killer, slowly accumulating in the heart of the giant. The myth of a peaceful end is shattered here. Some believe all stars explode. Only the most massive ones, at least 8 times heavier than our Sun, face this violent destiny. Smaller stars, like our Sun, will simply puff away their outer layers and leave behind a glowing core. But for our massive giant, there is no gentle fading into the night. The iron core continues to grow. It sits there, a dense metallic sphere, roughly the size of the Earth, but weighing more than our entire solar system. It is supporting the unimaginable weight of the millions of miles of star material pressing down on it. It is holding its breath. There is a fundamental limit to how much weight this iron core can support. This is known as the Chandrasekhar limit. When the core's mass exceeds about 1.4 times the mass of our Sun, the laws of quantum physics break down. The outward pressure of electrons, the very force that keeps atoms apart, is suddenly overcome by gravity. In a single terrifying instant, the core loses all its structural integrity. The balance that held the star together for 10 million years is shattered. The stage is set for the final act. What happens next occurs in the blink of an eye. The entire iron core, a sphere the size of Earth, suddenly collapses. It falls inward on itself, and it falls fast. Imagine standing on a bridge, dropping a stone, and watching it fall at nearly 1/4 of the speed of light. That is how fast the core collapses. In less than a single second, a sphere thousands of miles wide shrinks down to a ball only 12 miles across. It is an implosion of unbelievable violence. The space beneath the outer layers of the star simply vanishes. With the core suddenly gone, the rest of the star loses its foundation. Millions of miles of superheated gas, weighing billions of trillions of tons, suddenly begin to fall in a catastrophic freefall. Imagine the ceiling of a massive cathedral suddenly caving in, millions of tons of stone plummeting to the floor. The outer layers of the star are rushing toward the center at millions of miles per hour. The sheer kinetic energy of this falling mass is beyond comprehension. The entire star is rushing headlong into the abyss. Down in the dark center, the collapsed core has become something new. It has been crushed so tightly that protons and electrons are forced to merge, creating a solid sphere of neutrons. This is the densest object in the known universe. Imagine taking all of humanity, all 8 billion people on Earth, and crushing them down until they fit into the size of a sugar cube. That is the density of this newborn neutron core. It is unyielding, it is absolute, and it is about to stop the falling star in its tracks. The millions of tons of falling star material finally hit the unyielding neutron core, and they hit it with impossible speed. When an unstoppable force meets an immovable object, the result is the most powerful shockwave in the universe. Imagine dropping a rubber ball onto a concrete floor. It compresses, then violently bounces back. The inner layers of the star smash into the dense core and bounce outward. This creates a shockwave that begins to rip its way outward from the center of the star. The explosion has begun. But this shockwave struggles. The weight of the outer star is still falling inward, fighting the shockwave. The explosion might actually stall. It might fail. But the newborn neutron core has a secret weapon. It releases a massive, silent wave of ghostly particles called neutrinos. Trillions upon trillions of these invisible phantoms flood outward in a fraction of a second. Imagine a silent, invisible tsunami radiating from a single drop of water. These neutrinos carry away unimaginable amounts of energy. A common myth is that we can see every part of an explosion. But the most powerful part of a supernova is entirely invisible. The neutrinos smash into the stalled shockwave, transferring their immense heat and energy into the gas. They supercharge the explosion. The shockwave is revived. It tears through the falling layers of the star, ripping atoms apart, reversing the immense inward collapse and blasting the material outward. The shockwave is a wall of destruction, moving at a significant fraction of the speed of light. For a few hours, the surface of the star remains unchanged. If you were looking at it from a safe distance, you would see nothing wrong. The star looks peaceful. But just beneath the surface, a wave of ultimate annihilation is rushing outward. Imagine sitting on a quiet beach, completely unaware that a mile-high tsunami is rushing toward you just over the horizon. The tension is unbearable. The star is already dead. It just doesn't know it yet. The light of the explosion is still trapped inside. And then the shockwave breaks the surface. The star rips open. The energy that was trapped inside bursts out into the cold vacuum of space. The sudden flash of light is so intense, so blindingly bright, that it defies all earthly comparisons. Imagine taking the brightness of our sun and multiplying it by 10 billion. In a single moment, the exploding star releases more energy than our sun will produce in its entire 10 billion-year lifetime. A supernova is born. The brightness is terrifying. If a supernova were to occur relatively close to us, say a few dozen light-years away, it would be brighter than the full moon. It would cast shadows on the ground at midnight. You could read a book by the light of a dead star. For a brief, glorious moment, this single exploding star outshines its entire host galaxy. Imagine a single stadium light bulb suddenly burning brighter than all the city lights of New York, Tokyo, and London combined. It is a cosmic scream, visible across the universe. Many people imagine that an explosion this size must be deafening. They picture a cosmic roar, an earth-shattering boom that shakes the very fabric of space. But here is the most chilling truth about a supernova. It happens in absolute, terrifying silence. Space is a vacuum. There is no air for sound waves to travel through. You could be floating just outside the blast radius, watching a star 10 times the sun violently tear itself to shreds, and you would not hear a single whisper. It is a silent film of ultimate destruction. As the shockwave blasts the star's guts into the void, it does something miraculous. The intense heat and pressure in the expanding blast wave are so extreme that they force atoms together in new ways. This is where the magic happens. All the heavy elements in the universe are forged right here in the fires of destruction. Imagine a chaotic, superheated cauldron where gold, silver, uranium, and platinum are created in a fraction of a second. The dying star is scattering priceless treasures across the cosmos. The expanding cloud of gas and dust is called a supernova remnant. It is a terrifyingly fast storm of radiation and matter, expanding outward at millions of miles per hour. Imagine a colorful, glowing storm cloud stretching across light years of empty space. As it expands, it sweeps up the cold, interstellar gas around it, heating it up and making it glow. These remnants form some of the most beautiful and intricate structures in the night sky. They look like delicate ribbons of colorful silk woven from the ashes of a dead giant. But what is left behind in the center? What remains after the fire has faded? When the smoke clears, a tiny, rapidly spinning sphere is revealed. This is the neutron star. It is a dead corpse of the core, furiously spinning in the dark. Imagine a sphere only 12 miles wide, but spinning hundreds of times every single second. It possesses a magnetic field trillions of times stronger than Earth's. It is a bizarre, extreme object that stretches the very limits of physics. It is the ghost of the star that once was. Some of these neutron stars become cosmic lighthouses. They shoot twin beams of intense radiation from their magnetic poles. As they spin, these beams sweep across the galaxy. If one of these beams sweeps past Earth, our radio telescopes pick it up as a steady, rhythmic pulse. Beep, beep, beep. We call them pulsars. Imagine a solitary lighthouse spinning on a dark, lonely ocean. When scientists first discovered these perfect, rhythmic pulses, they actually thought it was a signal from alien life. But it was just the heartbeat of a dead star. But the story can get even darker. What if the original star was truly a leviathan? What if it was 30 or 40 times heavier than our Sun? In that case, even the incredibly dense neutron core cannot withstand the crushing force of gravity. The collapse doesn't stop. Imagine the core shrinking smaller and smaller until it literally punctures a hole in the fabric of the universe. The mass is crushed into an infinitely small point, a singularity. A black hole is born. A black hole is the ultimate terror of the cosmos. Its gravity is so intense that nothing, not even light itself, can escape its grasp. Imagine a region of space where the rules of time and physics simply cease to exist. It is a perfect, invisible trapdoor in reality. Any light from the exploding star that falls within a certain boundary, called the event horizon, is lost forever. The black hole silently consumes the ashes of its own parent star, leaving a sphere of absolute, perfect darkness in the glowing wreckage. Sometimes, the birth of a black hole is accompanied by the most violent beam of energy in reality. It is called a gamma-ray burst. As the star collapses into the black hole, powerful magnetic fields channel the energy into two tight, focused beams shooting out from the poles. Imagine an apocalyptic laser beam capable of vaporizing anything in its path for thousands of light years. If a gamma-ray burst were to strike Earth from a few thousand light years away, it would instantly strip away our ozone layer, ending life as we know it. This brings us to a terrifying question. Could a supernova happen near us? Could our sky suddenly light up with a lethal dose of cosmic radiation? The nearest star capable of going supernova is Betelgeuse, the bright red star in the shoulder of the constellation Orion. Imagine stepping outside on a crisp winter night, looking up and seeing Betelgeuse suddenly shining as brightly as a second moon. It would be a breathtaking sight. It is expected to explode soon in astronomical terms. Perhaps tomorrow, perhaps in 100,000 years. But there is no need to panic. The universe is terrifying, but it is also vast. Betelgeuse is over 600 light-years away. At that distance, its explosion would be a spectacular light show for humanity, but perfectly harmless. The lethal radiation would be scattered and absorbed long before it reached our fragile blue marble. Imagine watching a beautiful fireworks display from the absolute safety of a distant hill. We would witness the death of a giant, completely insulated from its wrath. In fact, we owe our very existence to these violent explosions. Remember the gold, the iron, the carbon forged in the heart of the dying star. When the shockwave blasts these elements into space, they travel for millions of years. Eventually, this enriched dust mixes with cold gas clouds. Imagine a gentle breeze carrying seeds across a barren field. This stellar dust begins to clump together, gravity pulling it into new spinning disks. From the ashes of the dead star, new solar systems are born. New planets take shape. A common myth is that space is just an empty, dead void. But it is an endless cycle of recycling and rebirth. The iron in the hemoglobin of your blood, the very iron that carries oxygen to your brain right now, was forged in the violent implosion of a dying star billions of years ago. The calcium in your teeth, the carbon in your DNA. You are not just observing the universe, you are physically composed of it. Imagine holding a piece of starlight in your own hands. You are made of the debris of cosmic apocalypses. So, what truly happens when a star explodes? It is an act of unimaginable destruction, a terrifying display of raw, chaotic power that can wipe out planetary systems and tear the fabric of space. It is a reminder of how incredibly small and fragile our existence really is. But it is also the ultimate act of creation. It is a beautiful, necessary sacrifice. Without the violent death of stars, the universe would be a dark, cold place, filled only with hydrogen and helium. There would be no planets. There would be no life. There would be no you. As we slowly drift back from the glowing, expansive clouds of the supernova remnant, let the rhythm of your breathing align with the slow, eternal heartbeat of the cosmos. The universe is a place of extremes. It is fiercely violent and profoundly silent. It is terrifyingly dark and blindingly beautiful. But in the midst of this cosmic chaos, there is a perfect, enduring order. The death of one thing is always the birth of another. When you look up at the night sky tonight, don't just see cold, distant lights. See the raging furnaces, the delicate balances, and the ancient ancestors of your own body. You are safe on this pale blue dot. The cosmic storms are far away, painting the canvas of infinity just for you. Thank you for joining us on this journey to the edge of destruction and back. If this flight through the stars brought you peace, please leave a like, subscribe to our channel, and let the universe know you are here. Now, tell us in the comments, when you look at the stars tonight, what do you see?